This is lesson 4.3, operations with functions. Okay, what we're going to learn today is how to add, subtract, multiply, and compose functions. Now you might think that dividing is missing. Dividing actually comes later because there are some special things that we're going to have to know about dividing functions. So we're not going to do dividing right now. Today we're going to mostly focus on that. Composing we'll talk about here and then also in the next section. So we're going to talk about some examples of functions first. So of course we know that you would write function notation using f of x, and that's of course the same thing as y. The reason why we write f of x is because that gives us a definite place to put our input, and that's equal to our output. So f of x is equal to y because we have the number we're going to put in place of x in our function, and we will get out a value. So g of x is equal to 5x. That would be the same thing as saying if you said something like g of h would equal 5h, or g of c would equal 5c. This is just our input variable. That's all that means. And then h of x is going to be this function. Now I'm just making those up. We're just using those. In the next problem they might be different functions. Okay, so we'll give you a definite, like, here's what f of x is for this problem. It's not always going to be 3x squared minus 4. All right, we're going to write our own function. So you can start out with f of x. You can call it g of x, a of x. It doesn't matter. We see a lot of different ones. So sometimes we'll do p of x if we're talking about the profit of something, or a of x, or anything else, j of x. It just depends. It's just like a variable. You can use whatever you want. So if I say f of x equals, make up your own. Just make something up. X squared minus 2x plus 1. There's my function. You can write your own. We're going to learn 4 operations that can be performed with functions. Again, the add, subtract, multiply, and then compose. So the functions that we're going to use here in this box, and this is just so that you don't have to keep looking to somewhere to find out what it is. So first of all, we're going to evaluate a function. So when we evaluate a function, we're putting a value in for the variable. So if I want to find f of 2, I'm going to take the function f of x, and instead of x, I'm going to put in 2. And then I'm going to find out what that's equal to. So 2 squared is 4, 3 times 4 is 12, 5 times 2 is 10, minus 4. So that's 22 minus 4 is 18. So that means that for this f of x, f of 2 is equal to 18. Okay, number 2, negative 4 times k of 3. So I'm going to be using my k function right there. So I'm going to do 2, and then instead of x, I'm going to put 3. So again, you're just putting this as your input value. You're putting that in for x. So I'm going to have negative 4 times 6 plus 1. Negative 4 times 7, which is negative 28. So I know that negative 4 times k of 3 is negative 28. Okay, go ahead and pause and see if you can do 3 and 4. Come back and check. Okay, for number 3, you should have done w of 0, so 2 times 0 to the second power minus 3, and then minus p of 4. So that would be 4 to the second power. So make sure you don't forget things like that. You don't want to forget to add that on. So once you put in for x, you don't want to forget the rest of whatever's there. 0 square, of course, is 0. 2 times 0 is 0. So I'm going to have negative 3 minus, this is 16. So that should be negative 19. And for number 4, this one gets a little bit confusing. You're going to have h of m of negative 4. So it's just like with parentheses. You're going to work from the inside out. So first find what m of negative 4 is. So I'm going to come up here and find m. And so I'm going to do 3 times x, which is negative 4, minus 4. And that's what m of negative 4 is. So that's going to be negative 12 minus 4, so negative 16. Now I'm going to find h of negative 16. So I'm going to take my h function, and I'm going to say 7 times negative 16. So that is negative 112. Okay, continuing on, we still have the same functions. I've just put them up here at the top so you can see. You've got them on your page though. The next set we're going to do, we're going to perform the operation. You'll notice that we don't have values in this one. We're still going to have our x's, and so that means that our answers will be in terms of x. So we're going to still have x. So if I have f of x, take away m of x, I'm going to take the function f of x, and I'm going to subtract the function m of x. Now when you're subtracting, one thing you have to be really careful of is you're subtracting this entire thing. And so that means that the negative gets distributed. So when you figure out what that is, you've got to make sure that you distribute that negative sign because you're subtracting the 3x and you're subtracting a negative 4. So that's going to definitely make a difference if you forget that. Combine your like terms and the 4's cancel out. And so that's what f of x minus m of x is equal to. So I'm going to come back up here and I'm just going to write this so I can erase the rest of this. Okay, moving on to number 6. We're going to take g plus m of x. So one thing I want you to write down is that this is the same thing as g of x plus m of x. So sometimes it's written one way, sometimes it's written another. It doesn't matter. It means the same thing. So I'm going to take my g of x and I'm going to add m of x. Now when you're adding, you don't have to worry about the signs like we did on the last problem. So I can just go around combining my like terms, simplifying it, and that's my answer. So this is going to be equal to 5x squared plus x plus 3. There's no value for it, so I just still have my input variable x, and that's all I'm going to do. Okay, go ahead and pause. You're going to be adding and then subtracting, adding, and then multiplying. So go ahead and pause this and see if you can get the right answers for them. Okay, I've got the answers written down to 7 through 10. A couple of things that I want you to notice. Number 8, you're taking something and taking away itself. No matter what your numbers are, if you take the exact same thing away, you're going to have 0. On number 9, I want to point out that if you have f of x plus f of x, you really have 2 times f of x. So if you think about it like that, all you're doing is you're taking f of x and multiplying by 2. And you know how to do that pretty easily without really writing anything down. On number 10, m of x times k of x. So you're going to take this binomial and multiply it by this binomial. And we've done that before. So you're going to multiply, simplify your like terms, and you get 6x squared minus 5x minus 4. Okay, we've got a few more examples to practice this. So on number 11, remember that this is equal to h of x minus k of x. And 13, this would be g of x times h of x. So just depending, it might be written differently. So 14 is going to be w of x times h of x. And same thing on 16. Okay, so go ahead and pause and come back and make sure you got the right answers. Okay, here are the answers to 11 through 16. Pay attention on number 12. You're adding, not multiplying. So make sure you do that. On number 13, watch your signs. On number 15, that's a binomial times a trinomial. So whenever you're doing something like that, you've got a lot more terms to keep track of. So watch your signs. Make sure your exponents are coming out right. And hopefully you did a good job on those. Okay, a last few to practice. Pause the video, come back, and just check and make sure you've got it. Okay, here are the answers to 17 through 19. Just make sure that as you're multiplying, you're getting your exponents correct. Number 19, make sure you're not just squaring or multiplying this part and this part. Make sure you got your middle terms in there. Otherwise, you miss having the negative 24x. In the next lesson, we'll do the composition of functions, but you're ready to do assignment for 4.3.